Good afternoon, class. So it's time for chemistry. I'm sure you enjoyed your day. And today we'll be considering two topics, air and water. But first off, we'll start with air. I'm sure we are familiar with air. Definitely we know air. The surrounding that surrounds the earth contains air. And air is a mixture. We all know that air is a mixture. Air is a mixture that contains some elements, which are oxygen, nitrogen, carbon dioxide, noble gas, water vapor, and impurities, depending on the location. Nitrogen is the most abundant because it is about 78%, whereas oxygen is around 21%. Carbon dioxide is about 0.003%. Noble gas around 1%. Water vapor varies, so variable, around 0.01 to 0.02. Air is a mixture. Why is air a mixture? Number one, it cannot be represented by a chemical formula. So evidence, air cannot be represented by a chemical formula. So whenever we talk about air, reaction with air, we usually use oxygen. And why do we use oxygen? Because oxygen is the most active element in air. There are various elements in air, but oxygen is the most active. Whenever we talk about combustion, let's say roasting, we know roasting is between iron and oxygen. Actually, it's air, but oxygen in air. So whenever I want to represent it using chemical symbols, we talk about oxygen. Air cannot be represented in air, and individual elements still retains their properties. So constituents still retain their properties. And one peculiar characteristic of mixture is it can be separated by physical means. So definitely air can be separated by physical means. Now, let's consider characteristics of air, right? So the properties. And when we are talking about the properties of air, because it's a mixture and each element still retains its physical properties, we'll be talking about the properties of oxygen, nitrogen, and carbon dioxide. We all know that oxygen supports combustion. So oxygen supports combustion, and also in respiration. Human beings breathe in oxygen. So also for respiration. Let's move on to carbon dioxide. Carbon dioxide is necessary for photosynthesis. So carbon dioxide is necessary for photosynthesis. Let's move on to noble gas. The noble gas present in air is helium and argon. Helium is used in filling balloons, and argon is a fuel, right? So water vapor, we all know water, uses of water varies from household to industries to companies to factories. Nitrogen. Nitrogen does not support combustion. Whereas impurity can either be H2S, hydrogen sulfide. It can be from exhaust, that's carbon monoxide, carbon dioxide, SO2, NO2. It can be hydrocarbons as well. So depending on the location, that will determine the impurity present in air. This is practically all about air. Let's move on to water, and after that, we'll then come back to questions. So let's talk about water. I didn't get you. All right, let me. All right. Sir. Someone said the network for my end is not good. That is going off and on.
Ask the others, are they having the same issue? Ask them. Who is the person that is sharing screen?
So is that only peculiar to Dorcas, or was it Adun that spoke, or is everyone also experiencing that?
Who is sharing screen?
What did you say? Ado. Okay, so Chris, are you also experiencing the same issue? Dorcas, are you also experiencing the same issue? Favor, are you also experiencing the same issue? Or is only Ado? Okay, so who's sharing this our screen? Please, can you? Okay, is it better now? Ado, is it better now? Okay, so can I clean the board? Can I? Okay. What did you say? What did you say? I didn't get that.
You cleaned the board.
Okay, so that will be evidence that air is a mixture. One, it cannot be represented by chemical formula. Two, individual constituents still retain their properties and it can be separated by physical means. Those are the three evidence to prove that air is a mixture. And so to the properties, I said for properties of air, since it's a mixture, so we'll be talking about properties of each element. Oxygen supports combustion. Oxygen is necessary for breathing, that's respiration. Carbon dioxide is essential for photosynthesis. Helium is used in filling balloons. Argon is used in electric lamps. Are we good with that? Can I continue? Okay. Someone told me you just joined food. Can you hear me if I talk? I've already muted. He said he just joined and I should retake the percentage.
Tell him that I can have that in the recordings, that there will be a song with the recordings, that when he gets the recordings, he can go through that place.
So let's continue now. We'll talk about water. Life needs water to exist. Both animals, both plants, we all need water. From the tiniest plant to the largest animal, which is blue whale, needs water to survive. This saying goes, without water, life will not exist. And that is true because everybody, once you can breathe, you need water. So what's water? Water, as we know, is H2O. And it's very essential. It makes about 70 to 90% of living organisms. About 70 to 90% of living organisms. Definitely that component is essential. And water is a compound. Air is a mixture, but water is a compound. It contains hydrogen and oxygen. Let's talk about uses of water. At home, we need it for cooking, baking, cooking, baking, washing, that's cleaning. Plants need water for medium in order to take in their nutrients. Water is the medium in which plants takes in their nutrients. They also need it for photosynthesis. For photosynthesis, it is CO2 plus water, right? So plants need this as well. And many organisms use water as their habitation. So all aquatic animals, they survive on water. Once water is taken off, definitely life will come to an end for them. And so I made mention for household, cooking, baking, washing, bathing, cleaning. Industries, virtually everything manufactured needs water. Anything produced, once edible or non-edible. Plastics, to paint, to boards. I'm trying to figure out marker, everything, including things that are edible, also chips. All of them need water because you need to first of all clean them, right? Even factories need water because after the work of the day, they need to cool down these large machines, and so they use water to cool down these machines. And so it is generally said that water is a universal solvent because it's very essential, right? Water is a universal solvent. I've made mention of some of the uses of water. Let's now move on to the structure of water. I said water is H2O, and we can say H2O is the oxide of hydrogen. The oxide of hydrogen. Let's consider hydrogen as an element. Let's consider oxygen as an element. Oxygen is the 8th element on the periodic table, and we can write it as 1s2, 2s2, 2p4. 1s2 will be like this. That's it. Electronic configuration. 2s2 will be like this. And 2p4 will be like this. 1, 2, 3, 4. This is 1s2, 2s2, and 2p4. In order for this p orbital, we know it's p orbital, to be fully filled, 1 electron is needed here, 1 electron is needed here, right? So that's 2 electrons. And into its shell, it will be, the first shell will take 2, the second shell will take 6. So 1, 2, 3, 4, 5, 6. So this is oxygen, right? And we have 2 atoms of hydrogen. We know hydrogen is the first element on the periodic table, and definitely it will have 1 electron. So let's take this to be the hydrogen with 1 electron. Another hydrogen with 1 electron. This hydrogen can bond with this, and this would bond with this, right? Because this is unpaired, this is unpaired, this is a lone pair, this is a lone pair. And so we can say a neutral oxygen, for its outermost shell, it has 2 lone pair, 1, 2, and 2 unpaired, 1, 2. And so this hydrogen can bond with this. It doesn't have extra, it only has 1. And we know for the first shell, stability would be 2 electrons, right? For this shell, since it's the first, stability is 2 electrons, and this is the second, so stability is 8 electrons. And so this can bond with this can bond with this. The bonding will be a covalent bond, and the peculiarity about covalent bond is that they share electrons. So this can 2 both bond, and this would bond. So this would have 2, and this would have 2. Imaginary 1 here, imaginary 1, right? Imaginary, so that they all will attain octet stability. Since there will be a covalent bond here and there will be a covalent bond on the other side. So they both would attain stability as a molecule. Don't forget, H2O is oxide of hydrogen. I'm sure we are clear on this. Any question on this structure? Before I move on, any question here? I'll take that as a no. Okay, so let's move on to types of water. Types of water. Types of water. Have you wondered anything? Okay. Have you wondered why rainwater will form ladder easily with soap and seawater wouldn't, or well water wouldn't? Rainwater will form ladder easily with soap, but seawater, well water wouldn't. Rather, it will consume more soap while washing. It's because they both are not the same type of water. They are water, right? H2O. They both might be clean, but they are not the same type of water. That means there's definitely types of water. There are definitely types of water. There are two major types of water. We have hard water, and soft water. Hard water and soft water. That means one will form ladder easily with soap and the other wouldn't form ladder easily with soap. As the name goes, soft water. Definitely to form ladder easily with soap. And hard water wouldn't form ladder easily with soap. Why wouldn't hard water form ladder easily with soap? Because there is something there. And so let's move on to talking about hard water. We know for sure that hard water will not form ladder easily with soap, but soft water would. And it's because of the presence of calcium ion and magnesium ion. That means it can be calcium ion or magnesium ion present, or the two present in the water. Either calcium ion or magnesium ion in water, and it must be in large quantity. So large concentration or high concentration of calcium ion or magnesium ion. And they also differ. So I made mention of calcium and magnesium ion. It must be a salt, and there are two types of hard water. Two types of hard water. We have your permanent hard water, and you have your temporary hard water. The hardness is as a result of calcium ion and magnesium ion. What source of water would that be? It would definitely be groundwater, because that's where you get these ions, either calcium or magnesium, and they are predominantly groundwater. That's your well water, seawater, ocean water, river water, because these are predominantly groundwater. So hardness comes, the source of hard water is from groundwater, either seawater, well water, ocean water, river water. We are familiar that seawater contains high level of salinity. That's what? High level of salt. But that cannot be said for well water. That means they vary in their concentration. Generally, hard water would have high concentration of calcium and magnesium, but it will still vary because of their source. And that will bring us to types of hard water. We have the temporary hard water and you have the permanent hard water. Let's consider the temporary hard water first. Temporary hard water, or you can say temporary hardness. Temporary hard water, that's water that contains, let me write it down. Water that contains hydrogen trioxocarbonate 4 of calcium ion or magnesium ion. Trioxocarbonate 4 is HCO3 minus. So temporary water is that water that contains trioxocarbonate 4 of magnesium ion or calcium ion. I made mention that hard water definitely will contain either calcium ion or magnesium ion. But for hard water, that means it contains hydrogen. Oh, I wrote hydrogen. Hydrogen trioxocarbonate salt of this, and hydrogen trioxocarbonate 4 of calcium will be CaHCO3 2, and magnesium will be MgCHCO3 2. Temporary water would contain calcium hydrogen trioxocarbonate 4 or magnesium hydrogen trioxocarbonate 4. And as the name goes, temporary hard water, that means the hardness can easily be removed. Hardness can easily be removed. Hardness can easily be removed. How can we remove temporary hardness? 1, by boiling. Or addition of slake lime. And slake lime is calcium hydroxide. So calcium hydroxide. Hard water, it contains calcium ion or magnesium ion. Temporary water will contain calcium hydrogen trioxocarbonate 4 or magnesium hydrogen trioxocarbonate 4. And it is called temporary because it can easily be removed. The hardness can easily be removed. How do we remove it? Boiling or addition of slaked lime. Now let's move on to permanent hardness. I'm sure there's no question. Or is there a question if I clean? Permanent hard water or hardness. So for permanent hardness, it contains, that means the water itself contains, let me write it down, tetraoxosulfate 6, that is SO4 2 minus, or chloride is Cl minus, of calcium or magnesium ion. And so calcium tetraoxosulfate 6 would be CaSO4. Magnesium tetraoxosulfate 6 would be MgSO4. Calcium chloride is CaCl2. Magnesium chloride is MgCl2. So permanent hardness contains tetraoxosulfate 6 or chloride of magnesium ion and calcium ion, whereas temporary hardness will contain hydrogen trioxocarbonate of either calcium or magnesium ion. And as the word goes, permanent, that means it cannot easily be removed. It is not permanent, like cannot be removed at all, rather it cannot easily be removed. Unlike temporary water, that can be removed, the hardness can be removed by boiling. Boiling cannot solve the issue of hardness in permanent hard water, rather the use of chemicals. So hardness cannot be easily removed, right? So to remove it would be